Hello and welcome to this video. This video is on the product rule. I'll begin by showing you when you should use the product rule, then I'll show you the product rule and we'll finish with a few examples. Let's begin. You want to use the product rule when you've got a function times by a function. So this could be expressed as fx times gx, or you might often see it as uv. Now we know when we should use the product rule. I'm just going to write down the product rule. You begin with the first function and you times that by the derivative of the second function. And then you add the derivative of the first function times by the second function. If you're doing it in terms of u and v, this would be u v dash plus u dash v. Say we have a function y equals x squared cos x. I'm going to write it out in full, every single step, so you can see how you do it. As you get used to the product rule, you can do it in your head, but for now, just so you can see how it's done, I'll write out every single step. I'm going to begin by writing out fx and df of x, as well as gx and dg of x. If you're using UV, the UV format, then f of x is u, g of x is v, df of x is u dash, and dg by dx is v dash. So going back to this example, f of x is given by x squared, therefore df by dx is 2x. Gx is cos x, therefore dg of dx minus sine. Now that we've got this, we can figure out dy by dx, differential. Using the formula, it's fx times dg by dx. So I'm going to put the minus sign in front. That becomes minus x squared sine x plus df of dx times dx, which is 2x cos x. Let's do another example. Y is x ln x. F of x here is x, so the derivative of that is 1. And gx is ln x, and the derivative of that is 1 over x. Using the formula, fx times dg by dx is x over x plus gx times df over dx, which is just ln x. And you can simplify that to be 1 plus ln x. Let's do another example. In this example, we'll do sine x over x to the n. I would rewrite this sine x to the minus n. So we're just going to bring the x to the top. Again, f of x here would be sine x. Therefore, the differential would be cos x. And gx is x to the minus n. Therefore, its differential is minus n x to the minus n minus 1. Using the formula, dy of dx will become sine x minus n x to the minus n minus 1 plus cos x to the minus n. And we can simplify this. I'm just going to swap them around so there's no minus sign at the front just to make it look nicer. Cos x over x to the n minus n sine x over x n plus 1. If you're wondering how I get the x n plus 1 on the bottom, I've just factorized the minus out of power at the top. X to the minus n minus 1 is the same as x to the minus n plus 1, all in brackets. And let's do one last example. The last example will be an important example. Last example, we'll do tan x. Again, I'll rewrite this as sine over cos, but I'm also going to then rewrite this as sine x sec x, because 1 over cos is sec x. Using this, f of x is sine x. Therefore, differential of f of x is cos x. G of x is sec x. And then the differential of this is tan x sec x. I ran out of room, so I'm just going to write it at the bottom. In case you didn't know the differential of sec x, you can look it up online, or if you have a formula sheet, it will be on there. Okay, using our formula, dy of dx is fx times the differential of dx. So that becomes sine x times tan x times sec x, which is really long. And then the second half is cos x times sec x. Factorize out a factor of sec. Now I'll rewrite tan in terms of sine and cos, just because I want to get it all in the same identities as possible. It will make things easier down the line. So tan is sine over cos, so this would become sine squared x over cos x, and then we're left with cos x plus cos x. I want to get rid of the bottom cos x here, so I'm going to take a factor of 1 over cos x out, and because I'm doing that, I need to times the second term by cos x, just so when you then multiply back in the 1 over cos x, you'll end up with just cos x. So this will become sec x over cos x, which we'll simplify in a minute. Therefore, we'll be left sine x squared plus cos x squared, which, as we know, goes to 1. Simplify sec x over cos x, therefore this becomes sec squared x, which if you do look at your identities, you will see that tan x, when differentiated, does go to sec x squared. That is the end of this video for today. I hope it helped, and if you do have any questions about the product rule, feel free to put them in the comment section down below. I'll try my best to answer them. And if you do have any suggestions of a video that you might like, also feel free to put it in the comments below and I will do my best. Thank you for watching and have a good day.